Welcome to AERO 2230 ProPilot 1, presentation number 8 on communication procedures. Almost all communication with air traffic control and the flight service station is done through the radios. And the radios that are used in aviation are very high frequency band radios. One problem with these radios is that they're limited to line of sight. What that means is any obstacles, any terrain that is between the radio and the antenna may block the communication. Pilots and air traffic controllers are required to use the phonetic alphabet when communicating on the radio. And the reason we use the phonetic alphabet is because many of the letters that we use when communicating sound alike. For example, the letter M, as in Mike, sounds like the letter N in November. Here are some examples of some tail numbers. The first one is November 582 Mike Tango. Second one, November 711 Sierra Bravo. And then November 32 Papa Echo. November 701 Delta Alpha. November 644 Romeo Mike. Kilo Mike Bravo Tango. And Kilo Romeo November Charlie. When flying under visual flight rules, you can request traffic advisories from air traffic control, otherwise known as flight following. It requires you to have an operating transponder, and they can't report traffic that's not displayed on their radar screens, so you must still remain vigilant for other traffic. Your transponder transmits a code called a squawk code to the air traffic controller on their radar screens. Air traffic control will give you a specific code when you're using flight following or getting traffic advisories. There are some codes that you want to avoid using in your transponder. 7500 is the code used for hijacking. 7600 is used whenever an aircraft loses radio communications, so their radios have failed. One way that they can tell ATC that they no longer have the ability to communicate on the radio is to squawk 7600 on the transponder. And the third one is 7700, which is the code for an in-flight emergency. So anytime you have an emergency, in order to attract the attention of ATC and allow them to identify where you are, you can squawk 7700 on your transponder. And then finally, 7777 is the code that you would squawk if you were ever intercepted by a military aircraft. It's important to remember, if you're receiving traffic advisories from air traffic control, that all they see on their radar screens is a return for your airplane. If you are adjusting for the wind, as in this illustration, and your ground track is 360, but your heading is 020, air traffic control may tell you, for example, that there is traffic at 9 o'clock. Normally you would look off your left wing for that traffic, but because of your magnetic heading, you would look behind your left wing at 8 o'clock instead of 9 o'clock. So it's important to keep this in mind. Aviation radio phraseology is a specific language agreed to by the international aviation community. It's not citizens band or ham radio slang. It's specific to aviation. And numbers and letters are spoken in specific formats. Altitudes are spoken in a precise form. For example, the number 9 is always stated niner. The number 5 should be stated fife, and that's to avoid confusion. And when we're calling different facilities, we use different terminology. So if we're calling approach control, we might say Nashville Approach. But if we're calling the Nashville Flight Service Station, we would call Seattle Radio. The same for calling for en route Flight Advisory Service, or EFOS. Instead of saying Seattle Radio, we would say Seattle Flight Watch. Altitudes in aviation radio phraseology are spoken with separate digits of thousands plus hundreds. So 4,500 would be spoken as 4,500 feet. Altitudes above 10,000 are said a little differently. Instead of 10,500, you would say 10,500. An altitude of 13,500 would be reported as 13,500 feet. ATIS stands for Automatic Terminal Information Service, and this is available at most controlled airports with a tower. The purpose for ATIS is to reduce frequency congestion so that controllers don't have to repeat the same information over and over again to different pilots. It's a recorded message, it's updated hourly, and it's available for pilots before takeoff and landing. Information like ceiling, visibility, wind, direction and speed, barometer setting, temperature and dew point is given on the ATIS, in addition to other information about the active runway and any other important information about the airport. Pilots are not only required to contact air traffic control in the air, but also on the ground at a controlled airport. Ground control handles all traffic on the ground at a towered airport, and you'll talk to them prior to taxi and also for takeoff and right after landing. You need to get clearance to taxi when you're ready to taxi for takeoff, and once you receive clearance to taxi, you can taxi on all taxiways and intersecting runways. It's not a clearance though to taxi onto the runway for takeoff. Once you get to the runway, then you need to get a clearance for takeoff. Cleared to line up and wait is another term that you might hear. That's a clearance to taxi onto the active runway and prepare for takeoff, but it's not yet a clearance for takeoff. After you land, then you'll stay on the tower frequency until you're told to switch to ground control. So don't automatically switch to ground after landing until you're told by the tower controller. Ground control frequencies usually start with 121 and then another number. So you might hear a controller say contact ground 0.9er. What that means is contact ground on 121.9er. At airports that don't have a control tower, there may be a frequency known as CTAF, or Common Traffic Advisory Frequency. These are frequencies used by pilots to announce their position relative to an airport, tell other pilots where they're located so other pilots can look for them and avoid them. Some common frequencies that you'll hear at uncontrolled airports are CTAF, the Common Traffic Advisory Frequency, and that's the most common frequency that you'll hear at an uncontrolled airport. And again, that frequency is used by pilots to announce position, let other pilots know what they're doing and where they're located. You may also see a unicom or a multicom. Those are combination frequencies that are used by pilots to talk to other pilots as well as talk to personnel on the ground. And then AWOS stands for Automated Weather Observation Station. At uncontrolled airports, instead of an ATIS, you might have an AWOS, which is a recorded message about the weather and information about runway use at an uncontrolled airport. You can determine the Common Traffic Advisory Frequency at an uncontrolled airport by looking at the sectional. In this picture, you can see the letter C in a circle stands for CTAF, or Common Traffic Advisory Frequency, and the frequency next to the C is the CTAF frequency, 122.8. Again, a unicom is a combination frequency. Most of the time, if you see a unicom frequency, it's also the CTAF, or Common Traffic Advisory Frequency. Again, you can use the unicom combination CTAF frequency to self-announce your position and any intentions on the radio so that other pilots know what you're doing. Some airports that don't have a control tower but have a flight service station on site could be designated as an airport advisory area within 10 miles of the airport. And the flight service stations are identified by blue boxes on the aeronautical chart. You can see here this would be the Raleigh Flight Service Station identified here underneath this box, which is the identifying information for the Elizabeth City VOR. The Flight Service Station frequencies are listed above the VOR identification box. In this case, you can see that you can contact the Raleigh Flight Service Station on 122.05, 122.2, 255.4 is for military aircraft. If you were to ever lose your radio and become unable to communicate with air traffic control, the procedures vary depending on your situation. If you're not in controlled airspace and you can land at an uncontrolled airport, then all you need to really do is squawk 7600, which is a squawk code for lost communications, and land as soon as possible. But if you lose your radio inside of a Class Charlie airspace or Class Bravo airspace, then we need to be able to notify ATC that we've lost communications, and there are certain procedures that we need to follow. We should still squawk 7600 on the transponder to let the air traffic controllers know that we've lost our radios, but then we should look for light signals from the tower to give us instructions on what to do next. If you're experiencing an emergency, for example an engine failure, it's important to try to contact the closest ATC facility to let them know what's going on so that they can send help. If you're already talking to air traffic control, let them know. Declare an emergency, and you'll receive priority handling. If you're not in contact with ATC and you don't know the local air traffic control frequency, you can always contact 121.5 on the radio. That's the emergency frequency known as GUARD. If you become lost, remember the 5 C's for lost procedures. Climb, because the higher we are, the more we can see, the better off you will be to try to identify your position. Communicate. If you're still lost, communicate with air traffic control, and then confess that you're lost. Then comply with any instructions that they give you, and try to conserve fuel as much as possible. It's important for you to memorize these 5 C's, not only so you can execute them if you're ever in a situation where you're lost, but they will also be on an upcoming quiz and test. You're not required to file a flight plan if you're just flying under visual flight rules, but it's highly recommended that you do file a VFR flight plan if you're traveling to another airport, because if you don't arrive at your airport at the estimated time, the Flight Service Station can initiate search and rescue operations. If you don't file a VFR flight plan, it may be a while before someone starts to look for you. There are a couple of ways that you can file a VFR flight plan. One is by phone, by calling the Flight Service Station. The other is through ForeFlight, the ForeFlight application on your tablet. Filing a flight plan is not the same as opening the flight plan. Once you file the flight plan, you still have to open it right after or as close to your departure as possible. You can do that via the phone, or you can call the Flight Service Station in the air. You can also call the Flight Service Station to get a standard VFR weather briefing, which is always a good idea because it includes the weather at your departure airport, your destination airport, and route weather. It also includes information about NOTAMs, any temporary flight restrictions that have been issued that day, all of the latest information. The number that you can call to get a standard weather briefing is 1-800-WX-BRIEF. Here's a copy of a standard flight plan form that you can use to file your flight plan with the Flight Service Station. It contains all the information that you will need to give to the Flight Service Station in order to file your flight plan. It starts with the type of flight, VFR versus IFR, aircraft identification number, so that's your tail number, the aircraft type, so let's say DA-40, true airspeed estimated when you do your performance planning, your departure point, departure time, your cruising altitude, and your route of flight, and then your destination and your estimated time en route. Now when you give them your estimated time en route, you may want to give them a little bit more time than you've estimated in your flight plan, just to give yourself some time to call them and close the flight plan after you land. Then any remarks about the flight, how much fuel you have on board in hours and minutes, any alternate airports that you might land at if you have a problem before you get to your destination, your name, your address, your telephone number, and your home base, and how many people number on board, and then the color of your aircraft. Now when you give them your aircraft type, for example DA-40, you also have to give them a code telling them what kind of navigation equipment is on board. And this is a list of different navigation equipment codes. For the DA-40, because you have a GPS, that would be GOLF, Global Navigation Satellite System with en route terminal capability. So it would be DA-40/GOLF. In aviation, we use a special time called Universal Coordinated Time, or UTC. UTC is local time at the 0 longitude, or at Greenwich, England. We discussed meridians when we were discussing longitude and latitudes. Well, meridians also divide time zones. And in some places, like in the United States, state boundaries can divide time zones as well. There's exactly 1 hour between each time zone, and in the U.S. there are 4 time zones: Eastern, Central, Mountain, and Pacific time zones. Also in aviation, we use a 24-hour clock, or military time. Instead of 1 o'clock in the afternoon, we would say 1300. Instead of 6 o'clock in the evening, we would say 1800. We use UTC time in aviation because UTC time is the same no matter where you're located. So if you're in Virginia, UTC time is the same as it would be in California. So in the Pacific time zone out in California on the West Coast, UTC is Pacific time, local time, plus 8 hours. During daylight savings time, Pacific daylight time is local time plus 7 hours. In the Mountain time zone, it is Mountain Standard Time plus 7 hours. And during daylight savings, it's Mountain Daylight Time plus 6 hours. In the Central Time Zone, during Standard Time, it's Central Standard Time plus 6 hours. And UTC during daylight savings is Central Daylight Time plus 5 hours. And then in the Eastern Time Zone, it's Eastern Standard Time plus 5 hours, but during daylight savings time, it's Eastern Daylight Time plus 4 hours. Here are a couple of YouTube links to videos that you can watch about air traffic control communication procedures. They're very informative. I highly recommend them, and they're also very entertaining. Next time, we will be discussing weight and balance calculations.